1950s Moscow, Soviet Union. Two prominent Russian mathematicians, Andrei Kolmogorov and Sergei Yablonsky, are debating over a problem that will become crucial in the field of computer science: the problem of Peribor. Peribor is Russian for brute force search, where a solution is found by going through all the possible answers, which takes exponential time. Think of NP-complete problems. Sergei Yablonsky, a World War II hero and a high rank in Soviet science bureaucracy. He was leading research in theoretical cybernetics at Moscow State University. He got interested in Boolean logic and its representation by switching circuits. The problem of minimizing the number of circuits with connection to Claude Shannon's a symbolic analysis of relay and switching circuits brought wide attention to Peribor in Soviet Union. In 1953, Yablonsky made theorems showing that the problem of minimizing circuits requires Peribor, and therefore it's NP-complete problem. In 1959, he claimed to have proof to it. The proof was criticized for the lack of evidence, but Yablonsky used his high rank in the science bureaucracy to promote his work. Andrei Kolmogorov, a great, well-respected mathematician, also a professor at Moscow State University, was opposing the proof by Yablonsky. Kolmogorov worked on the theory of algorithms and believed in its potential to solve the complexity of Peribor. He helped develop the subject of algorithmic complexity, which brought new ideas to tackle the unsolvability of Peribor. This new idea came from Leonid Levin. Born in Ukraine, Levin got interested in mathematical logic in 1963 while in the 9th grade at a boarding school in Kiev. He moved to a boarding school in Moscow the following year, where he first contacted Kolmogorov with questions about logic. Levin was determined to become Kolmogorov's student, and in September of 1967, while finishing his sophomore year at Moscow State University, Levin tried to bring Kolmogorov's attention by proving theorems on commutative properties. Kolmogorov liked Levin's proof and agreed to mentor him. In 1967, Kolmogorov brought the problem of Peribor to Levin's immediate focus, and the young scientist started his research. In complete isolation from any work done by Stephen Cook or Richard Karp, Levin published several papers on NP-completeness in 1971, within months from Cook. Russian mathematicians recalled their excitement about Levin's discovery by saying they were entering NP era. At the same time, Levin finished his PhD thesis, but due to issues with the Soviet authorities, Levin's PhD defense was denied for his bad political image. Afraid that he will be completely denied publication, Levin rushes to finish his work on NP-completeness and publishes his universal search problems in 1973. Levin's work was slightly different from Cook's, although both defined NP-completeness. Levin also described 6 problems that are NP-complete. Levin emigrated to the United States in 1978, where he got his PhD at MIT and currently teaches at Boston University. In 2000, Clay Mathematics Institute announced 7 Millennium Prize problems in mathematics, including P versus NP problem with the prize of $1 million. So why is the P versus NP problem so important? Imagine a very efficient world. Everything here is fast and optimized. The environment is less stressed. People have found a cure to any cancer. Finding algorithms to solve NP-complete problem in polynomial time could make this a reality. Predicting protein structures in p-time will allow finding a cure for cancer. Solving the traveling salesman problem will make a huge progress in routing and logistics. Finding a path in p-time will enormously speed up the networks and deliveries. Efficient scheduling will optimize resources and cut pollution. Proving P equals NP will bring unprecedented changes in cryptography. Modern cryptography is based on factoring large numbers, which is an NP problem. Having a way to factor the numbers in polynomial time will open any cyber-secure system. Google, Facebook, Amazon, governments all will be exposed. Even proving that P is not equal NP is also beneficial and will show us our limitations in computing and bring new ideas.